Hey y'all. Today's today's objective is dilations. We're going to finish up the transformations we've been talking about. A transformation is a change of a figure, and we have already gone over reflections, translations, and rotations. Today we're going to talk about dilations. A dilation is a shrink or a stretch. So if you have a figure and it stretches or it shrinks, that's a dilation. If you've ever gone to the eye doctor and they dilate your eyes, they put little eye drops and they make your pupils get really big. So that would be a stretch, and that way they can look and see inside your eye better. That is a dilation of your pupil. The image is similar. So for these three, reflections, translations, and rotations, those were all congruent figures. Same size, same shape. Same size, same shape. But for dilations, it's actually, we're changing the size. We're stretching it or we're shrinking it. So the shape is going to remain the same, but the image is similar. And this is the symbol for similar. It's just the little curvy on top of the equals, except that's it. So if you have two shapes that are similar, you're going to see this little, it's called a tilde. You're going to see that little squiggle. And how you know how big or small the dilation is going to be, it's called a scale factor. It's the ratio of dilation. So scale factor. That's a scale factor for a stretch or a scale factor of a shrink, then that's how you're going to know which way to go for the image. But we're going to talk about that. So if you had a triangle, let's just say this is your triangle, A, B, C. A shrink would be a smaller triangle, still similar, and a stretch would be obviously a larger triangle, still similar, but this is what we're going to be talking about is a dilation. So the red triangle would be my pre-image, my original, and then I could either shrink it or enlarge it, and those are the dilations. So we're going to get started straight with the key concepts. So pause and copy this down. You're definitely going to want to have all this information. Pause it. Key concept for dilations. To dilate a figure, you multiply the coordinates of each vertex by the scale factor. Sometimes the scale factor is going to be referred to as K. I have no idea why they picked K, but you might see SF, you might see K, so I'm just showing you both. You have to multiply each vertex, the coordinates of each vertex. So if it's a triangle, like I just showed you, you'd have to multiply all three vertex coordinates by the scale factor. Now, if the scale factor is greater than 1, do you see that? If the scale factor is greater than 1, that's a stretch. The scale factor is bigger than 1, scale factor of 2, scale factor of 3, it's like 2 times as large or 3 times as large. It's going to be a stretch. So, for example, if you had this point A and the scale factor was 2, then I would multiply both coordinates by 2, and A prime would be 2, because 2 times 1 is 2, and 2 times 4 is 8. So my new coordinate, A prime, would be 2, 8. If the scale factor is less than 1, if the scale factor is less than 1, that's a shrink, that's a reduction, an enlargement or a reduction. If the scale factor is less than 1, the dilation is going to be smaller. The new image is going to be smaller. So for example, if the scale factor is 1/2, that means your new image should be half the size of the original. So if you have a point, 1/4, and you are going to dilate it by scale factor of 1/2. You're going to dilate it by scale factor of 1/2. That means you multiply each coordinate by 1/2. 1/2 times 1 is 1/2. 1/2 times 4 is 2. And you could write 1/2 or you could write 0.5, but the point and this whole shape would be a shrink, it'd be a smaller, and we would say the scale factor is less than 1, and so we would know that. Here's how you write an algebraic notation. If you have a point, xy goes to p prime, kx, because remember you multiply kx and ky. So that's how you would write it algebraically. Let's do some examples using our algebraic notation right here. All right, this says example. This is example 2, but really it's example 1. So, 1. Example 1. Find the coordinate of the image. That's supposed to say coordinates. I'm just messing up everywhere. Find the coordinates of the image after the given dilation. So I'm going to go through A and B with you. Notice on A, my scale factor is 2. You should know in your brain, okay, if my scale factor is 2, it's bigger than 1. This should be an enlargement. This should be a stretch. My points all should get bigger. And so when we do this, R prime, we have to multiply all the coordinates by a 2. So R prime, negative 1 times 2, negative 2. 4 times 2 is 8. So those would be the new coordinates of R prime. S prime, multiply them both by 2, and S prime would be 6, 8. Multiply T, the coordinates of T, by 2, by the scale factor of 2, and T would be 4, negative 6. So that is how you find the new coordinates. You multiply the scale factor by all the coordinates of all the vertices. The scale factor is greater than 1, so this is a stretch. If we were to graph the original triangle and then the image of the dilated triangle, this triangle would be twice as big. Let's do this one together. The scale factor K is 1/3. Since this is less than 1, this is going to be a smaller. We're dilating by a scale factor of 1/3, so my new triangle should be 1/3 the size of the original triangle. R prime, S prime, T prime. So I'm going to multiply 6 times 1/3, 1/3 times 6. So that's really 6 over 3, which is 2. So 2, 2. Looks like Z's. S prime, I'm going to multiply 1/3 times 3 is 1, and 1/3 times 2 is 2/3, because 1/3 times 2 is 2/3. And it's okay if you have 2/3. If you were graphing it, you wouldn't quite go all the way over to 1. And T prime, negative 2 times 1/3 is negative 2/3. See, it's okay to have negative 2/3. And 1/3 times 3 is 1. Those are the new coordinates for a dilation by a scale factor of 1/3. Notice I didn't have to graph anything. I just took the scale factor and I multiplied it by all the coordinates in the shape. All right, copy this down. These are you tries. Whoops. I don't know why my numbers are off. You try to, without graphing, find the coordinates of the image. So I've given you 2 problems, and I want you to do these on your own. Pause it, time out, find the new coordinates of the dilated figure, and then press play to see the answer. All right, scale factor of 1/3, triangle DEF. This would be a dilation by 1/3, so hopefully you visualized it's going to be 1/3 the size. This is a shrink, a reduction. D prime, negative 1, 2. Check your D, E, and F prime. I multiplied them all by 1/3. 12 times 1/3 is 4. 6 times 1/3 is 2. And the negative, just you bring the negative over. And B, the scale factor 4, this would be a stretch. And L prime, 8, negative 4. M prime, 12, 8. And N prime, 8. No. Whoops. Where's my eraser? Multiplying by 4 would be 16, 4. And notice my negative came over, and they all got larger. So a couple of things. If it has a negative, you just keep the negative. A scale factor is not going to be negative because the scale factor is telling you how much bigger or smaller to transform the figure. So you're not going to have a negative scale factor. Also, what do you think would happen if the scale factor was 1? So I told you if the scale factor was larger than 1, it would be an enlargement. If the scale factor was smaller than 1, it would be a reduction or a shrink. So what would happen to the figure if the scale factor was 1? And so if you can tell me that next time we're in class, I will be interested to hear what you have to say. All right, see you next time.